Cities has evolved over time through the lens and hand of human-centric design approach. New technologies has become embedded in our society over the past 10 years, are starting to reshape how we use and experience the city. They start to generate new collective intelligence amongst us, also reviving other urban actors' intelligence. Can we resurface in London public space based on this computational paradigm shift? Mochen seeks to find a new balance between how we design future cities through a combination human and ecological intelligence, using advanced machine learning to mediate the needs of both urban participants. First, we use a neural network to learn the comprehensive features of nature landforms and urban fabric. Training and synthesizing, we try to keep existing building blocks and to a great extent while improving nature features. The results showed an improving index in the test set.
Previous feature learning allows us to extend the testing area for urban mobility and rethink the relationship between movement and space with different material. Since we are resurfacing London in order to be more inclusive in terms of biodiversity, the data should represent different intelligence not only from the human and machine movement, but also the animal migration paths. We used the different tools including Twitter location data mining, spacing text simulation, agent-based simulation, and electronic circuit algorithm to respectively simulate the pedestrian movement, autonomous vehicle and cycle, and urban animal movement on the new public space that have been redefined through the feature learning. After getting these movement data from multi-intelligence, we start to setting up our interface with 3 steps. The data mediation comes first. This importing mobility data can be translated into parameters and values that ties in with a relational understanding of space and time, and each group of input data has its own adaptability, representing its own intelligence. We weight these values as giving voice to the different urban agents, like giving voice to folks, for example. It shows whether you listen to the other type of intelligence and design with compassion. And then the metadata analysis network, which not only look into the urban agent's data but also the environment layers of the site, alongside with the space-time value for these agent movement and environment data. All these values and parameters constitute the metadata. These metadata can be used to help understand the context in which data is created and used, as well as learn the relationship and how to communicate with the data. Through the metadata, we can also sort the data and find unseen relationship behind the data. Data points are the frozen moments that show us the different possibilities, and values point to the fact that something is held to deserve its importance or worth of something for someone. And then the scenario and the suggestion to fit into different scenarios will require different suitable value and data range. It also linked to the third part that we try to bridge between metadata and the materialization. Under the influence of multiple parameters of time and space quality, we predefined the urban surface and explored the spatial proposal under the joint decision-making by multi-intelligence. We analyzed the behavior patterns of different species and explored the classification and the connection of different materials. We also use the evolutionary algorithm to find suitable surface and classify them according to the changing tendency of the shapes and the suitable materials for different intelligence. Similar for human and autonomous vehicles. We can see the combination of materials are reshaping due to how the metadata is changed and how we filtrate. We analyze the activity points in different locations to reshape the entire urban surface in London in order to be more inclusive in terms of biodiversity and provide different quality of public space. In this way, we are setting up a cross-intelligence urban design method and interface.